Symmetric key algorithms rely on a shared secret. Picture an encryption key similar to that of your house door. Given this same key is symmetric, that means it can be used to open and close the door, aka encrypt and decrypt a message, for those who have access to this same shared key. CISSP exam tip: the keywords are shared and secret. Why? Well, to explain, let's use an analogy. Of love. Oh yeah. Imagine we have Mr. Smith and Mrs. Jones, and they've got a thing going on. And they both know that it's wrong, so they use a secret shared key for when they meet at the same place. This secret key is only shared between the two of them, which means they can encrypt and decrypt their secret rendezvous, unless another party gets access to the same shared symmetric key. CISSP exam tip: the larger the key, the harder it is to break. Perfect for confidentiality of love affairs. So how exactly does the symmetric encryption work? Good question. Think of the encryption and decryption algorithm as the love algorithm, which starts with a naughty plaintext message in an envelope that is to be sent from one party to the other. But since these two know their love affair is wrong, they need to encrypt that secret message using a secret love key rather than sending in plain text. Mr. Smith and Mrs. Jones each have a copy of the same shared symmetric key, which is used to encrypt and decrypt their communications. CISSP exam tip: in some cases, an ephemeral or temporary or disposable key, if you like, can be used for a session and disposed of after the communication ends. Now let's review the pros and cons of the technicalities of symmetric key encryption, starting with the number one benefit, which is speed. But speed kills, right? Which is why there are lots of problems on the side of the benefit. You see, the more parties that are involved, the more number of keys that need to be generated, and per the mathematical formula, this means the more affairs, the more keys, the more problems. Just look at this example of how many keys would be needed if Mr. Smith and Mrs. Jones multiplied their secret love affairs across multiple people. But if it's just the two of them, then they only need one pair of symmetric key, which is shared and used for both encryption and decryption, giving them the speed benefit for their secret rendezvous. But here are all the downsides. You see, firstly, in order for the keys to be exchanged or distributed, ironically, the secret key needs a secret channel when being first passed between the two communicating parties. This may not always be possible, and sometimes a offline key distribution is used, known as out-of-band exchange. The next problem lies in the lack of non-repudiation, which means that nobody actually knows the true origin of the sending party. All they need to know is that the sending party had the symmetric key, which mathematically corresponds. For this reason, symmetric keys must be regenerated often to avoid this problem. And again, the algorithm is clearly not scalable. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.